Spark ML on Spark 2 introduces a bunch of new concepts that you might have encountered in other machine learning libraries. The higher level abstractions such as ML pipelines, estimators, and transformers. Before we dive into these concepts, let's first understand how our machine learning workflow functions as a pipeline. We have data which we collect in the raw form. This data is then transformed. These transformations typically form a directed acyclic graph or a network. The edges of this graph represent the actual data which flows through this graph. All of this data is represented using data frames in Spark ML. These data frames flow through this network and are transformed along the way. Every transformation will change the data frame in a certain way, add new columns, aggregate old columns. All of these operations are performed by the computations, which are the nodes of this directed acyclic graph. These computation nodes that act on data frames in this pipeline are estimators or transformers. These are the higher level abstractions that work on data in data frames. When you talk about Spark ML, there are five main concepts that make up the machine learning workflow: data frames, transformers, estimators, pipeline, and parameter. Hopefully, you're already familiar with the concept of a data frame, which stores data in a tabular format in the form of rows and columns. A data frame is used to represent the ML dataset that we use for training. There are different columns within the data frame that are used to represent the features that go into training our algorithms, the actual labels that correspond to our training data, and the predictions which are made by our ML algorithms. You'll see when we actually implement the ML models that all of these will be columns in a data frame. Often the raw data that you collect before you feed it into your machine learning algorithm needs to be cleaned and summarized. Transformers are the algorithms that you use to convert one data frame to another. This conversion can take on many forms. You might want to encode categorical values as numbers. You might want to represent text in numeric form. All of these will use transformers. Transformers are also used to convert data frames which contain your features to a resultant data frame which contain the predictions from your machine learning model. An estimator is a slightly harder concept to understand. It's more abstract. It is an algorithm that fits on a data frame, looks at the data within a data frame, and produces at its output a transformer, another algorithm that is able to change the data frames in some manner. An estimator learns from data and produces another algorithm which has the ability to change data based on what the estimator learned. Machine learning algorithms in Spark ML are all estimators. An ML algorithm trains on the input data, learns patterns within it, tweaks the model parameters, and produces a model. A model is essentially a transformer which makes predictions. In Spark ML, a trained model is a transformer which takes a data frame with features and produces a data frame with predictions attached. A pipeline is basically a network which chains estimators and transformers together to form the machine learning workflow. These estimators and transformers are basically the series of operations that we want performed on data stored in data frames. You can think of a parameter as a design setting for any machine learning model. Depending on the algorithm that you choose, they might have different parameters. These are design settings that can help you tune your machine learning model, and this tuning is called hyperparameter tuning. Spark ML makes it simple to use parameters by having a common API across transformers and estimators. A machine learning pipeline in Spark is made up of estimators and transformers. Each of these have their own stages. We'll compare and contrast them in order to understand them better. The estimator takes as its input a data frame, and at its output, we get a transformer. A transformer takes a data frame in and gives a resultant data frame out. All estimators implement a fit method. This method is used to train on the input dataset in order to produce a transformer. All transformers implement a transform method which changes the input data frame and produces the resultant output data frame. And it is this fit method that an estimator uses to get a trained machine learning model. Fit is what starts training on the input data set and produces a trained machine learning model, which is our transformer. Transformers can be used to change the features of the model in some manner or also to carry out prediction. You get predictions in Spark ML by calling the transform method on a transformer. An important point that I want to reiterate here about machine learning pipelines is the fact that they are all directed acyclic graphs. Notice the edges in the graph, they're all pointed in one direction. There are no cycles. That's because if you have a graph which has a cycle within it, that graph will never finish computation. Our data frames will simply go round and round within those three nodes. Let's say you were planning on building a machine learning pipeline for sentiment analysis of reviews. Here are some standard steps that you'd find within that pipeline. We'd first take the documents, which are the reviews themselves, and split them into individual words. Machine learning models do not accept text as input. We'd have to convert these words into some numeric form. We'll create feature vectors after encoding these words. Once the data has been prepared, we are now ready to train our machine learning model using our training data corpus. The result of this step will be a trained machine learning model that we can now use for predictions.